Our speaker this evening holds 7 patents, has previously held senior roles at MapR, IBM Informax, and Sybase. Please welcome the Senior Director of R&D for Couchbase. I'm going to try this. Keshav Murty. Thank you.
Thank you, Eric. Glad to be here in New York. As advertised, I'm going to be talking about going from SQL to NoSQL, specifically on the query language, right? So, SQL, you call the relational databases as SQL databases for a reason. So in today's talk, it's going to be focused on the query language and access to it. Before I get started, a couple of announcements. So you see Bob and Mitch. Bob and Mitch, please raise your hands. After I talk, if you have further questions, interest in Couchbase, please talk to them. And also, this late October, we're going to have a big conference in Silicon Valley on October 25th and 26th. There's going to be 6 all-day hands-on workshop on Nickel, mobile, operations on Couchbase, the whole 2 days of Couchbase immersion. As well as 6 different tracks on the second day, 30 different technical presentations, not just from Couchbase people, but also from customers, right? Customers who have done production deployments, their lessons, their best practices, they're going to come and share their information as well. So with that, let's get started. Maybe I should have added this as a quiz. So Don Chamberlain was a co-inventor of SQL, right? I used to work for IBM, so I had a chance to meet with him, and I asked him, what was the secret of success for SQL? There are many declarative query languages that were trying to implement on top of the relational model. What was the secret of success? What he said was when he and Raymond Boyce came up with SQL, he talked to IBM, other researchers, the product teams, and they said, this looks interesting, some English-like query language for relational systems, but we are not interested in implementing this, so go ahead and publish it. There's no problem. So he published it, and then a small company in Bay Area, there was a guy leading that. He thought this was the IBM secret plan to take over the world with the relational database technology. This SQL was a secret sauce of IBM. So he went and implemented it first. He took the action to implement the SQL on top of relational systems. And in fact, IBM was not the first to release the product with SQL support. And he deservedly got a big vote for his effort. He's Larry Ellison from Oracle. Even Don Chamberlain didn't do too bad. He got a vote himself. He became an IBM fellow. But that's kind of the story. Like, action has much more power than just words. So Oracle and Don Chamberlain, Raymond Boyce, they all deserve a lot of credit for coming up with these great ideas of SQL over relational systems, right? In today's talk, I'm going to briefly talk about SQL origins, what SQL means today, just so that we are on the same page. Then motivate why NoSQL was started, and get into the migrational aspect of moving this schema first, moving the data, and then getting to our query language on top of NoSQL data model. Majority of my time on the latter subjects in terms of moving from relational model to JSON model, moving from SQL to Nickel. So let's get started, right? So very briefly, right? This is the history of, this happened over the course of 10, 15 years initially. COD developed the relational model based on the relational algebra. He published almost a few people understood, but they knew it was much impactful compared to a navigation model that hierarchical databases and other databases had. But that relational model, Cod himself proposed a language to manipulate the data, right? Let me give you an example in a moment. So if you have a question like, find the total volume of items of type A sold by departments on second floor. I've actually extracted this from the original paper from Don Chamberlain and Raymond Boyce, but this was the question they had, right? In the Cod's query language, you had to write a query like this. This involved setting up those variables and working through those variables. Also, it required understanding of the predicate calculus, right? How many of you studied predicate calculus before you wrote your first SQL statement? Right? Okay, 3 people. That's good. So the idea was, it's hard if you go through the rigor of predicate calculus. You could write the programs, but it was hard. So that's the reason Don Chamberlain, Raymond Boyce came up with a more English-like query language, right? See, if you see the original paper, their motivation was they wanted a structured English query language, right? Something that people can relate to, right? And one that is that can help you manipulate the data, and the target is not just professional programmers. Target, if you see at the end, for both professional programmer and infrequent database user, right? So the whole idea was to make the data accessible, right, to both programmers, programs, as well as infrequent database users. And also, some of the guys who studied relational calculus, so your professors would always be telling you, this is not tables and rows, this is relations, sets and relations, right? That's what people talk about. But I also found it interesting that they talk about tabular structures. That means they wanted things to, Don Chamberlain, Raymond Boyce, they wanted things to be more accessible to the users. They wanted tables and rows, much more familiar concept for the general user than making it very academic, right? So relational database, SQL and relational databases have become almost synonymous, even though they are different, but SQL is the main language used by all relational database systems, right? So I will tell you the SQL as a language is less than the SQL that you know today, right? This is a kind of a conundrum. Let me explain what I mean. SQL as a language initially targeted for data manipulation, data definition, as well as data manipulation. But when people say SQL database, right, we mean SQL as a language plus transactions, stored procedures, triggers, views, optimizers, spatial search, storage optimization, SMP, MPP, distributed query processing, drivers, the tools, the whole SQL ecosystem, right? And this is a sign of success of SQL. SQL has grown from just being a small language to manipulate the data to being a language where you can develop applications for online transaction processing, right? Online transaction processing is very important. To borrow the phrase from Bruce Lindsay, life as we know it depends on SQL and online transaction processing, right? So we can't catch our cab, pay for the cab, go somewhere without using a database that uses SQL and online transaction processing, okay? So SQL, the original paper was in 74. Oracle released its database with SQL in 79, but the standard itself was 1986, and there have been 7 major revisions. Standard has gone from a small book to a 6-volume book in the last 7 updates. So I won't bore you with all the details. Okay. So SQL databases themselves are very successful by any measure you take. It has changed the life of the industry. Back in the 90s, we used to have big Wall Street Journal advertisements from Oracle, from Sybase, from Informix, touting the TPC benchmark. So TPC, the SQL databases really drove not only the database industry, so the computer industry itself, right? Intel came up with new chips, InfiniBand, everything was created to support and get the best database numbers. But why do we need NoSQL despite having SQL? After the .com, there was need for new use cases. There were use cases like the shopping cart, the number of users, the large number of users, the scalability, and requirement not to have any downtime, right? SQL databases, especially transactional databases, for most part, ran on a single system. Yes, Oracle did the Oracle rack, but again, the scalability was still a problem. Flexibility agility, scalability, performance, and availability. These were the four most important drivers for NoSQL, right? As much as flexibility that SQL provided, the SQL itself was flexible. You can join any tables to any tables on any keys. You didn't require to have predefined relationships and so forth. But the schema itself per table was rigid, right? If you had to change your schema, you needed an exclusive lock on the table. That means you need to lock the table. That means application cannot run downtime, Saturday night upgrade of the schema, right? That was not acceptable, right? So second thing is elastic scalability. You don't want your capacity to be capacity of your machine or the cluster to be to match the peak demand, right? Your peak demands are usually the Black Fridays or the day after Christmas. You don't want to have the machine capacity to match the highest peak performance 365 days a year. You want it to be elastic, and as your demand grows, you want it to just scale out your cluster capacity rather than simply rip and replace with the scale up. Right? So NoSQL aims to do that. Instead of having, you can simply, when you want more demand, you can simply add new nodes. Whether in the case of Couchbase, whether adding to new data nodes, new index nodes, we'll talk about those things later on. But most NoSQL or all of NoSQL databases try to provide scalability one way or the other through adding new nodes. Many of your applications in relational systems, for example, when you have to model a customer, right? Customer is a very complex object, and when you have to store customers, you normalize the schema, and a complex object is stored into 10, 20, 30 different tables. What happens when you have to assemble a customer object? You have to fetch the data from multiple tables and join them together. Those can cause performance issues as well. I have a large electronics manufacturer whose criteria is minimum they want to have 100,000 reads and writes per second at sub-millisecond latency, right? And even if they grow their concurrent reads and writes, they still want to maintain the sub-millisecond latency. I know they measure it because once our 95th percentile read latency went from 500 milliseconds to 600 milliseconds, they complained, right? So they measure it. So each millisecond is very important to them, right? So each millisecond, and they know it translates to customer experience, and it has revenue as well. So these are quite important. And then availability, right? So applications downtime on Saturday nights, that used to be typical for a long time in database system, relational systems. That's no longer a choice. Your application has to be available 7 by 24, right? Of course, we want all this, but sometimes we hit into laws of physics, real theorems which we can't overcome. One of those theorems is CAP theorem, so which says, in a distributed system, there are 3 variables, so availability, consistency, and partition tolerance. And for us, partition tolerance is a requirement. If one partition goes down, we can't say the database itself goes down. We need to have the application and the data continuously available. So that means all the NoSQL systems choose either availability or consistency. Our Couchbase core data service itself, we choose consistency. Right? So we are a CP system. The data you get from the code data is consistent, and for the few seconds when if a node goes down, for the few seconds when we are failing over, that small portion of the data will not be available. We have indexes that's going to be available, but if you want to get the real full document, for the few seconds that data will not be available. So a few seconds later, when the failover really happens, that data was also available. So in that sense, we are a CP system. And there are other workarounds. I won't go into it. You can have multi-cluster system. So when you have multi-cluster system, your application itself is highly available, whereas your portion of the data may not be. So that's a longer discussion. So with using this landscape, there are different types of NoSQL databases that have been developed: document, graph, wide column, and key value. Couchbase, Mongo, DynamoDB, DocumentDB, or Cosmos DB, we all choose some variation of JSON. So our document model is based on JSON, and definitely for Couchbase, and Mongo has uses a variation of JSON called bson. Bson is an internal representation, but from the application point of view, it's JSON. Okay. So these were the kind of the high-level motivations for NoSQL. And before I get into the query language, I just want to give an overview of where it is used, right? Where exactly it is used in an enterprise, right? Because if Oracle provides SQL transactions and all the features, where do you use NoSQL database systems, right? So take, for example, right? How many of you went for summer vacation? Okay, majority of you. Rest of you, I'm sure, are planning for winter vacation, right? So, from the time you think of booking for a summer vacation or any vacation, till the time you book, imagine the journey you go through, right? You first talk to your friends or Google and try to see where are the nice spots, and then come to a short list, and then you talk to your family, talk to your and then find out what is the price range, what is the availability, is it a fun place. You do so many searches in all the different websites before you finally say, this is it, this is where I'm going, right? Once you spend the 20 minutes to take out your credit card and buy the actual tickets, right? And then you follow with other activities, and then actually go on a vacation. And this process from thinking to booking, maybe 2 weeks to 2 months, and then you go to your vacation, and then you come back, right? When you go through this cycle, the systems that you touch in an enterprise, for example, Expedia, right? You are searching. You actually, in some sense, Google is the biggest system of engagement, because you are searching for information. You're not, every time you search, you don't necessarily buy anything from Google. Google is kind of a forwarder to something else, right? So from Google to Expedia to actual booking sites, whether it's Southwest or any airline tickets, or even just Expedia itself, when you're searching, you're going through different systems of engagement. And airline people tell us the conversion rate is like 1,000 to 1. You do 1,000 searches before you buy one ticket, right? So these systems have to perform at a very high performance, high concurrency, but because there are so many searches before the buy is done, you also have to implement it at a cost-effective way, right? That's where all the NoSQL systems really bring you in. But has some people used NoSQL systems to implement system of record? Absolutely, right? But you have to understand the pros and cons of the features and where every product is at its evolution and to implement it. And going back to the original Larry Ellison slide, action speaks louder than words, right? So just downloading and experiencing and actually trying out has much more power to it. So this is kind of the context. When I talk to customers, this is what I say, right? So if you want to implement a SAP's ERP system on a NoSQL system, we are not ready there yet. But if you want to implement all the search systems, customer support, and tracking systems, those are all the things that you can implement on Couchbase and NoSQL systems. Okay. With that introduction, let's me move to the concrete data models, how you can migrate from a SQL data model into a relational model. Okay. So we talked about customer a while back. So let's take a customer object as an example. So if you have a customer object from application point of view, what are the things you want to have with this customer object model, as well as what do you want to do with it, right? The object itself has a rich structure with all the attributes and substructures. You want to represent relationships with other data for orders, connections, purchases, and so forth. The values can be evolved. That means values can be updated, insert, update, delete stuff. And the last but not the least, structure itself can evolve, because the definition of the customer you had today, the model you had today can evolve. You want to add new types of information into the customer. You want to modify the structure of the information that you had. Initially, you may have modeled for a single credit card for a customer. Tomorrow, you may want to have multiple credit cards for a customer, right? So things can evolve as the business needs. Can you model this in a relational system? Absolutely, right? You can represent a rich structure by normalizing the model and representing the information in multiple tables. And you issue join queries to zip and unzip, to zip up the data to create the model, as well as you normalize the data to insert and update data into individual fields. Relationships are well represented. Value evolution is pretty straightforward, insert, update, delete. But the problem comes in terms of structure evolution. Whenever you need to change the structure of your customer object, you need to do alter table. For most alter table commands require an exclusive lock on the table. That means you say, okay, yes, if there's a business need that you need to modify your structure, say, okay, sure, we can do that. We'll have to plan for it. We need a downtime. That means you cannot respond to the business needs as fast as the business requires. So the database becomes the bottleneck. In the entire stack, from top to bottom, you can add new web servers, you can add middleware, but the database, if you cannot alter it, that becomes the bottleneck. Okay. How many of you used or familiar with JSON? Okay, 95%. Quickly, right? It's used to represent object in a textual format. It is fully text, so any higher level can understand and operate on it. At a simple case, you can represent any value with key value. The strength of the JSON comes in. Okay, it has got the basic data types, number, strings, and Boolean, but it also has objects and arrays. Objects, a JSON itself is an object. It can have objects. Objects can have arrays. Arrays can have objects, and they in turn can have arrays. That's where the power of JSON comes in, right? You can, in this case, I have billing, which is an array of objects, and address is a simple object. So they can go up to n level nesting without any modification, and it is hierarchical. Okay, so when you have JSON, what happens is you don't have create table, right? Each document is self-describing, right? So this is what we call a schema on read, right? In relational systems, you first create the table, and then you create the table, define the columns and its types, and then you insert. Here you say, okay, I have a collection or a bucket with bucket, and then you don't define individual schema because they are self-describing. From document to document, like one customer to another customer, the fields can go missing. So let's try to transform the structure that we had into this, right? So you can represent this row as a simple key value pair, or you can have objects if you like. It's all simple key value pair. Now I have billing and end-to-end relationship, right? Each customer can have multiple billing cards, so that naturally becomes an array within the same object, right? So this one-to-end relationships can be represented here, right? Yeah, here's the example, right? So this customer CBL Jane Smith has two credit cards which are two different objects within a billing array, right? And when you need to add a new type, right? In this case, let's imagine we didn't have connections to start with. We had to add connection to the object. It simply is adding a new attribute connections and making it you can go in one customer document. You can have simply an object. In another customer object, you can have an array. In terms of evolution, you can, as long as you stick to the JSON model, you can simply keep modifying, and your application has to understand it. That means your query language has to read and understand this flexible model. We'll talk about that in a moment. And how can you represent relationships, right? So yes, you can aggregate or denormalize the customer object into a single JSON, but you still have other objects, right? You have customer object, inventory object, parts object. You can have relationship with them through references to those documents. Just like how you have foreign key relationships in SQL, here you don't have explicit relationship. You just have a reference to it. Okay, so this is the summary, right? So from your customer relation object, object, which was represented through 5 different relational tables, you can transform into a single object in JSON, right? Let's look at the summary of it, right? You can represent both rich structure in both relational and JSON model, but the difference here is whenever you want to get the customer object in NoSQL, you simply get the JSON document instead of having to join 5 different tables in the relational model. That's where you get the performance benefit. It's a simple lookup rather than a join, and joins tend to be expensive. In terms of relationships, relational database is all about relationship. They represent and model that well, and SQL provided all the capabilities within it to support relationships. In JSON, it is represented as well as, before having a query language like Nickel and SQL++, it was difficult to join objects of different types, right? If you have objects of different types, you have to implement that in your application. So we'll talk about nickel in a moment. Value evolution, data update is fine, and structure evolution is where the rubber meets the road, right? So the relational model is rigid, whereas NoSQL model is flexible, and you can change it dynamically, right? And even for those of you who have data in relational systems, you have one-to-one relationship, one-to-n, n-to-m. All of those can be done in NoSQL systems as well, in Couchbase specifically. One-on-one is pretty straightforward. You embed the document. One-to-n, you saw the billing example. Customer had n billing objects. You can have an array of those objects. And when you have n-to-m, each of the type of objects have an array of references to each other, right? That's how you can model all of the three types of relationships in Couchbase, right? Okay. Now that we have covered the moving the model as well as moving the data, let's see what is the motivation for a query language within NoSQL, right? There was a reason people said, we don't want SQL in this new kind of database. I mean, at least my theory about that was, people wanted to solve the shopping cart and the scalability problems. And SQL, because it was well defined, it had the rigid structure through those standards defined over 20 years, it was difficult to implement all the SQL semantics, support everything in a short time, right? And even NoSQL industry had to understand what it means to have a SQL on top of NoSQL, right? So that's the reason they said, okay, the problem of NoSQL is so severe. I mean, the problems we are trying to handle is so severe. We need to implement a database that scales, that performs for these use cases, but will forgo SQL, right? So our motivation comes from, how many of you have gone to your business leaders and said, well, we have a new database called NoSQL. You need to change your processes. You need to change how you run the end of the day, end of the month process. You need to change how you call the inventory, right? I mean, your business do not change, right? If you have data in your NoSQL systems, you still need to answer the business questions, right? You need to know how many things you are going to ship in the next 24 hours. You need to know what you sold in the last 24 hours. Right? Business questions do not change, and it's, well, difficult to say, well, we have lots of data, we don't know what's going on in the business. We are taking a lot of orders, we don't know how many orders are due tomorrow. Or I have to dump everything into a different system where I can ask the question, right? So this was the motivation for us to say, okay, well, if you have a lot of data in NoSQL systems, you need a language that can help here, right? At its core, what does SQL do? Input to any SQL statement is sets of relations. And SQL engines take your statements, take the data, do the processing, and give you back another relation, right? That's true of any SQL statements. What was happening in NoSQL systems was, well, we have a lot of this different objects, customer object, orders, loyalty info, everything. From NoSQL API, we'll do gets from each of those things, and you had to implement data logic to join, to aggregate, do everything. I've met a lot of customers who actually did that when NoSQL system did not have this sophisticated languages, right? These are hard to write, hard to test, hard to maintain it, and expensive, right? So again, by using the simple get and put methods, the application industry went back into the procedural language. The beauty of SQL was you told the system what you wanted, how you wanted to, or what you wanted, and system figured out how to execute your statement and give you the results that you expected, right? Another simple example, right? If you want to find all the high value customers with order than 10,000, right? If you had just get and set APIs, you had to query all the customer objects from the database, and for each customer, find all the orders within the customer, calculate the total for each amount, and then sum up the grand total of all these orders. And then if it is more than 10,000, then extract the customer data. Otherwise, ignore it. And you had to implement your own logic to get it. What happens if a different question? For each business question, there was a program, right? So this was complex and obviously inefficient, right? I mean, going back to the original motivation, right? If SQL's idea was to provide a easy to use English-like query language to access relational model, why not have a high-level language, a declarative language, which helps you to do the same on JSON, right? That's the purpose of NiQL, right? NiQL provides a query language that operates on JSON and gives you back JSON. The goal is to give developers and enterprises expressive, powerful, and complete language for querying, transforming, and manipulating JSON data, right? That's the main motivation for us. The idea is to give you back a complete steering wheel for your data, right? You don't want to be manipulating the wrench all the time. You want your steering wheel. So, even though we were pioneers in terms of having SQL-like language, SQL-inspired language to manipulate NiQL, there are a number of initiatives, number of our competitors, other universities, they are all doing R&D on this. So there's a good ecosystem on this. Okay. Well, like I said, if it was easy to implement SQL on JSON, everybody could have done it. There are a number of things that we have to think about, and since this is schema on read, even application developers, data architects, DBAs, you have to think about what happens in a NoSQL store as well. Each document can have its own schema, right? So it's self-describing, right? You can have customer documents, and there could be a little bit variation here. Whereas rows in a relational table, they're all exactly same. Some of the columns nullable columns can have nulls, but here this could be totally missing. Second thing is nested objects. So you can have objects containing other objects, containing other arrays. So the structure could be complex, because real world is complex. And when we have SQL on top of this JSON, we need to have SQL operators on these nested objects as well as arrays, right? So the language has to understand these things. And then, since NoSQL databases are generally distributed systems, the query engine has to work on a distributed system, as well as have the right optimizer to optimize the query for the distributed system, right? This is a query language that has to work on a distributed database system. Okay. So the actual query engine itself has to interpret the JSON document by document. And also, one thing that is different from a relational system is, relational system has, each column can have a value or null, right? And in each Boolean expression, like in a where clause, right, you can have the result of an expression could be true, false, or unknown, right? True nulls are never equal, right? If you compare A to compare a value, is 1 equal to null? It's false. The underlying mechanism says, okay, it's unknown, that is transformed into a null value. Here in JSON, you could have a value that is missing, right? So there's a difference between null, that means we know this value exists in the JSON document, it's a null value, versus this value is totally missing. So we've extended the actual Boolean algebra to account for the missing values as well. Yeah, so nested objects array. So what happens is in here, your field names become your column names, right? In relational systems, you have, if you have a table of column A, B, C, they are the actual columns you are defined. Here in the JSON documents, if you have a field name called name, you refer to them as customer C.name. If you have a nested object, you say dot, it becomes a dotted expression, right? Dot address dot zip. And if you have an array, let's say you have an array with multiple values, so you say phone of 0, right? It becomes a standard array reference, right? So you had a question there.
Yeah, when you say missing value, that key, there is no, that key is not represented in that document, or there's a key and there's just no value, or is that null?
Yeah. So in JSON, if you have a key, you need to have a value. That's the key value, right? You can have a null value, it becomes a null value. If the key is not there, it becomes missing.
Then that's missing.
Missing. And that is one trick to, when you update a document, when you want to remove a value from the document, that's a shortcut for you to do it. When you want to remove, you set that to missing. Right? Set that to missing, and we updated it, that actually go missing. Okay? Now, so those are the considerations for a language on JSON. So we'll dig into Nikhil now. Yes?
The status in the previous example, was that right?
So in this case, yes. Yes. So in this case, yeah, we'll get into that detail in a moment. But yeah, if you have an array, you need the right predicate. You need a right array predicate to manipulate it, right? So in this case, I have status of this customer is got multiple status. I need to find out if this customer has, or I'm interested in all the customers who have a premium status in their status array. Yeah, that's the any predicate, right? It's not an equal predicate. If any of the values in the array has premium as a value, so then that document qualifies to be in this.
What is purchases?
Okay, so purchases. So if you, let me see if I have the document here. Okay. Well, let me go back. Okay. Instead of purchases, I could have said address not missing. It just means that there is a attribute, there is a field name with purchases. I don't care about value. I just want to make sure I'm interested in the customers who have done some purchase.
So we're looking at C dot address and C dot purchases.
Okay, that's a good point. Why is it purchases and not C dot purchases? So here in this query, it's got only, from clause has got only one key space, so it's kind of implicit. It's a good practice, so you can have C dot, but it is implicit. When you have a single table in even relational systems, right? Actually, even in relational systems, what happens is even if multiple tables, because the columns are predefined, it will try to resolve. If there's a conflict, then it will complain. Otherwise, yeah. I mean, but it's a good practice. Yes.
With JSON documents, is the expectation that a single JSON document has all the customers in it? Or could
Okay. So the question: should the single JSON document has all the customers in it? Answer is no. I mean, for some reporting purpose, you could have it if it's needed, but normally when you model, each document contains a customer, right? That's the typical model.
So when you're running a query like this, it's actually getting all the documents about all the customers?
Yes. Yeah. So this works like, I mean, query languages works on sets, right? So I'll explain, well, let me explain when it comes to that moment, okay? Okay, so we'll talk about, some of the enterprises using Nickel, mainly on, and then I'll focus on features, indexing, and everybody's favorite topics, transactions, and then go from there, okay? So, okay, we have, it's going to be 2 years since we went GA. We have hundreds of customers who are using our enterprise version in production, as well as we have a very solid community. So we release this in our community edition as well. So we have our customers using our community edition in production as well. Okay, so let's look at simple select statement. Okay. So I've said select star. Star means the same thing that you mean in SQL. So that means I want the whole document out, right? From customer C, right? In Couchbase, you first create a bucket and then you put in your data. So let's assume there's a bucket for customers. You put in all your customer documents in here. So that's the from clause. And it means the same thing as in SQL. Where c.address.state, right? Here is where things are a little bit different. It's close enough. It means the same thing that as in SQL, where c.address.state equals New York, right? That's the filter. But this is a dotted notation. Address is an object, and that object contains state equals has a state field, and we are interested in New York customers. And in this case, right? I have a simple field called premium. I want the status to be exactly premium. And then I'm ordering this by c.address.zip, right? So the selection clause, the from clause, the where clause, and the order by clause mean the same thing that it means in SQL, right? We do the selection, any joins, and projection in the same way, and then we do the order by before we project. The difference here is c.address.state is a dotted notation for the objects. But there is second important aspect. What happens if my customer doesn't have the address? Right? What happens if my customer doesn't have the address? It's missing. And missing is not equal to New York. So that doesn't get projected. What happens if the status is missing? Missing is not equal to premium, and that doesn't get selected, right? And we need to check for that. Okay? And then same thing, and then we do the order by on the zip field. So that's okay. Let's look at a little bit more complex example. So here we have 3 fields that are the group by fields below, and then we have an aggregate, right? We have selected ID, last name, first name, and then aggregate of the amount. And next is, here is where the richness of the language comes into picture. If you have arrays, right? How do you manipulate arrays? How do you extract the values from arrays? How do you join with the arrays? So we have 2 operators, unnest and nest. So what happens is, in this case, orders has an array of line items. So now I'm unnesting the orders.line items as order line. The moment I have given this name, I can reference the order line anywhere in the query. And then once I have the order line, I can do joins, just like your relational joins, right? I can do inner join with customers and orders.customer ID. Each order has got customer ID stored in it. So that has the child to parent relationship. I can do the joins here. Where customers are New York, group by means the same thing. having a clause means exactly the same thing. It will do the aggregation, and then post aggregation it will do the filtering based on the aggregate value, and then do the order by, right? So this is we have extended the SQL to operate on arrays, but you get the rest of the select, join, project operations within SQL. And SQL is highly composable, right? You can have subqueries in the projection, subqueries in the from clause. You can have correlated subqueries, non-correlated subqueries. You can do all that, and we support both inner join as well as left outer join, inner nest, left outer nest within Couchbase, and rest of the things we mean. And we actually spend a lot of time optimizing the limit and the offset. If you have the right index, we do the optimization for order by and limit. Let's question: how many of you develop or deal with pagination in your applications? Pagination is like when you have an application, you run a report, and when you search in Google, you get the first page. You want the first page to come very quickly, as quickly as possible, right? That's pagination. At least part of the pagination. And then people click next. How many of you deal with pagination feature in your applications? Well, some, okay. So yeah, there's a separate topic, but we do a lot of optimizations within that as well. Yeah. So so just like SQL, in the from clause, I mean, in SQL you can have any number of joins, and this our unnest operator, which unnests the arrays into a flat value. You can have any combination of unnest and join within a query. So for this helps your query processing. Okay. Okay. How do you insert a value into the document? I mean, Nickel is not just a query language that supports select. It supports select, insert, update, delete, merge as well. So you have to come up with a unique document ID, and then the complete document is here, right? The whole complete JSON document. So there is no need to predefine these things. It's just a complete JSON document, right? Again, update works just like SQL. I'll talk about the transactionality of it later on, but essentially you update the document and set any specific field. The field you set can be a nested object, an array, or anything else. So you can update the values. Your insert can be a single document insert, multi-document insert, or you can have select into a bucket, or insert into a bucket, select from somewhere else, right? So you can do insert into select for your ETL purposes. Okay. So, as I mentioned, we support joins and subqueries. For aggregation, we support min, max, sum, count, average, and array aggregate. Array aggregate means all the values that are in that group. We don't do min, count, and average, but we just combine them into an array and give it to you for, it's easier when you say, I want to group by customer, and I want an array aggregate of their hobbies, right? String values come in as an array, right? Array aggregates help you to do that. And in terms of the set operators, in union, all, intersect, except, all the standard ones that you have. I mean, for those of you who have already tried Couchbase or know Couchbase as a data platform, the main operator is get and put the whole document, right? The get and set, and we also have a sub-document API. Within Nickel, we also have a use keys option where you can get to the data directly. If you know the document ID, you can get to the data directly without having to go through an index. unnest flattens the data, and nest creates the object underneath another object. So it's a inverse of unnest. Nest and unnest are inverses. So earlier we saw a predicate saying where any C in status satisfies C equals premium. That's the array predicate. So arrays require a slightly different predicate, right? So for every scalar value is like a simple value. You can have equal to or a range predicate. Whereas if you have arrays within an object, you need a new kind of predicate, because you need to know whether a certain value exists in an array, or whether values are above, whether every value within the array are above certain value. So that's why we have provided any predicate which will be true if any of the values within the array satisfies to that. Or we also have every predicate. That means every value in the array has to satisfy that predicate followed by that satisfies keyword, right? We have array expression to manipulate the specific values within the array, and within helps you to traverse objects and arrays in a complex expression. Okay. So these are the basic data types of JSON, right? Numbers, strings, Boolean types, null, and arrays and objects. For every enterprise application, your date time handling is very important. So you represent your date time handling in ISO 8901 format as strings within JSON, and we have compared ourselves to compare the functions and arithmetic operators on the date time to other database systems. We have a lot of functions to convert the string into numeric values and do the arithmetic expression on the give me the next month, give me 7 days from a given days. All those common operations are supported within Nickel as well. Okay. Yeah. So this is another important thing. So let's say you had the zip code as numeric value, and then suddenly you had customers from abroad for whom zip codes are alphanumeric, right? So how do you do those two, right? We have within a data type, we first group the different values of the same type and then compare. For example, if you say zip code greater than some value, first we compare the type and then we compare the actual value. So there is a precedence within that. In terms of all the data manipulation statement, like I said, update, delete, insert, merge. So all these are supported. The complete syntax is well documented. We'll come to the transaction in a moment, because when you update and delete in relational systems, you have multi-statement multi-update transactionality. Either the statement completely commits or nothing happens. What happens in Nickel? So we'll come to that. Okay, this we covered already. So it's when you insert, it's a simple document. Yeah, let's take a look at how we execute. Right, language is good, but it has to work. Right, it has to work to run your application. Couchbase is a distributed database, as I mentioned. So here we have in a Couchbase cluster, we have, let's say at this level, 3 main services: data, query, index. We also have search service that's going to go GA in 5.0. Right now we have data, query, and index. You can deploy all these 3 different services in a single box. I have everything running on a single laptop. For a production deployment, you want to size it and deploy it on different systems, right? And the SDK simply know which service to talk to for each of the application requests and do that automatically, right? So let's see if with this given cluster, how does a query execute? Customer, your application issues the query, your client is application written over our SDK. Underneath, we have a protocol based. This application sends the request to the query. It does the parsing analysis and creates a plan. Just like a relational system, we create a query plan. If you are using the index, we send a scan request. We get the back, and then if we do require to fetch the document, right? If the query can be answered completely with the data with the index, we don't even go to the data service. This is the covered query case within within the database system, right? We have the same pattern as well. If the index has all the information to answer your query, we just do the index scan, and if needed, if we go to the data service, fetch the documents, and then do the post join, right? There can be some filters that could not be evaluated by the index, we apply the predicates after we fetch the data as well, and then send the results back. This is not so different from a relational database system, except each of the services are distributed, and we communicate through messaging, right? What happens inside of a query service, right? When the query comes in, the typical parsing, semantic analysis. Once we do semantic analysis, scans, joins, post-scan or post-join filtering, pre-aggregation, aggregation, we try to parallelize. We always parallelize the fetch from the data service, and you can configure the query system query to parallelize the query as well for complex queries, and then we follow it with aggregation, sorting, and final pagination before projection.
Are those data services and index services replicated?
Yeah. Question is, are data services, index services replicated? Here, different boxes means there are a number of data services, right? So data within data service can be replicated. It's typically replicated. That's how you get the high availability, right? You set the replication back to 2. Indexes can be replicated till 5.0, which is going to come out in a couple of weeks. You had to create multiple indexes with the same signature to get duplicate indexes. With 5.0, you simply say, create these indexes, make it 2 copies, just like how you do with the data service. So we create multiple copies, yeah. The answer is yes for both. Yeah, so this is kind of the inside of the query service. Okay. One of the big things, big difference between relational systems and NoSQL is we have to forgo not only SQL but also transactions, because the moment you have transaction is I won't go into too much detail. This is a all-day talk by itself, but basically you have to implement the whole ACID properties, right? Atomicity, consistency, isolation, durability, yes, right? But the magic is to putting it all that together as well. No, it's from a application point of view, it is ACID properties. From an internal perspective, you need to have latching, logging, redo, undo logs, all the for multi update statements, and not only statements, multi-statement with multiple transactions. In NoSQL, since you have, in SQL, what happened was each customer object you would shred into multiple tables. You normalize and put into different tables. We saw in our case, all the customer information is in a single document, and we provide single document atomicity. Right? When you write to a customer object, it's either all or nothing at one document level. But when you issue an update statement, in Nickel, if the node goes down after updating 3 documents, those 3 documents remain committed. Right? If you have given update to statements, but you only updated 3 statements, those 3 documents remain committed when the node fails over. That's the difference. But even without transactionality, we have, even without multi-statement transaction, like I said, we provide single document atomicity. We also provide different levels of different consistency levels for your index scans, right? So if you see let me go to the, here, if you make update to the data, the index has to index it. The index is asynchronously maintained. That means index is always little bit behind the actual data, right? Index is a little bit behind the actual data because these are asynchronously maintained. So what we have done is, when you do the index scan, you can specify what kind of consistency you want to have. Do you want, when you say unbounded, that means give me the data you got. I don't need the latest and the greatest. That means your data could be few seconds stale, right? That's one thing. At plus means read your own writes, right? If you have updated and you want to refresh your screen, so you say, okay, make sure you catch up to my last update and give me at least my own reads. Request plus means, okay, I'm giving you the request now, catch up to all the database changes up to now. Right now is the timestamp, and then give back to me. So in terms of the performance, an unbounded gives you the best performance and request plus, right? So this is what happens, right? You can, when the application specifies any of the consistency levels, the query service, when it sends the request to the index service, it sends the consistency level required, and index itself implements the snapshot isolation level. So it scans the data by complying to the consistency level you provided and gets the results back. If you specify at plus or request plus, if we have to go to, when we get the qualified index, we always go and get the data from the data service and return you back, because the data in the data service is always consistent, right? You don't get stale data, because remember, going back to the CAP theorem, we are a CP system. We are consistent and partition tolerant. So you always get the consistent from the data service. Okay. You can have any query service that is complex and sophisticated. Query service don't have the right indexing, right? Our indexing model, if you know the relational model and how to create the indexes, so this is quite straightforward and easy, in the sense we have the same similar approach to index creation, indexation, as well as picking up the index based on our in our optimizer. So you had a question.
I just have a question with the stale option. So does it store it in memory? So that's why it's
yeah. The question was, when you have the stale equals, okay, when you have the unbounded, right? Unbounded as the option, does it store in the memory? No, answer is no. Stale means you had the snapshot, right? It could be on a disk, it could be anywhere. Just get me the data by scanning the latest snapshot you have, right? Snapshot of the data. Well, a snapshot could be, that's kind of implementation detail, right? It could be memory, it could be a disk, but you don't have, if you're doing a lot of updates, you don't have to wait to catch up. give me the latest consistent snapshot. That's what it means. Yes.
Is that there a performance hit when you target the data without targeting the index first?
Sorry, I didn't.
You said, in regard to the consistency, you want to have the data up to now, you said.
Yes.
This one must be different. By not looking into the indexes, doesn't it mean that there would be a performance hit?
Okay, well, if you don't have an index, you need to know the primary key of the documents that you're interested in. If you know the primary key of the documents you are interested in, you can simply say select star from customer, use keys, give the list of the keys, and it will give you the consistent data from the data service. Right? You have to know something, right? Okay, so here I have a index with 2 fields, and fields can be anywhere in the object, and then the index creation, index matching is, for every query you need to have leading keys in the predicate, right? The index matching rules are very standard. It's the same as relational system, right? Just for clarity, you can have a primary index. Primary index is the index on all the documents in the bucket. You can have secondary indexes on the fields within the document. You can have composite index that are kind of extension to this. You can have a functional or expression based index. So that means the keys are not just simply the values, but an expression on top of it. Here I've just said upper for a case sensitive case.
Another question?
Yes.
So for the primary index, so you can't pick a column that can be missing, right?
Okay, well, primary index is an index on the document key of the documents. In Couchbase, for every document that you insert, you need to have a primary key. Without that, it will get rejected. So that's why primary key will have a pointer to every document in the whole bucket. Right? That's why keys are optional, because it's there. We know it's definitely there. So partial index is, in addition to the key specification, you can also specify a where clause, where you specify, and this where clause can be pretty complex, and the queries, we will check the queries, use this predicate or a subset of this predicate to make sure before we select the index. And partial index is also a easy way to manually range partition the index. And we talked about so normally index will have one entry per document, right, in the scalar field, right, one entry. But for arrays, each document can have n values. So index will have n values within the index pointing to the same document. That's why you have to specify, you need to index every value within the array, and this underlying in the first case I'm indexing all the hobbies. In the second case I'm actually indexing the result of an expression, right? The tokens is a field that returns the array of hashtags from this array, and I can index those as well. Right? So we support, supporting index on individual elements of an array is a big difference compared. So when you have an array, you want to be able to find out. Now I'm interested in customers who have who have skiing in their hobbies. So you need to be able to efficiently get that. So array indexing will help you. Yeah, so we also have duplicate. We talked about duplicate indexes earlier, as well as covering index and covered query. Whenever index can, for the unbounded consistency, when index can answer your query completely, we avoid going to the actual data service. Okay. Apart from the basic types, objects or arrays are a big differentiator. I'll go through quickly, but I'll share the PowerPoint. So we have talked about this, so this should be pretty straightforward, right? So arrays, sorry about the color here. Objects are an easy way to represent one-to-one relationship between multiple values between two different attributes of an object, and you can access individual fields using dotted notation, right? Here I say select h.geo, right? In this case, when I do the h.geo, I get the whole object. If I do the h.geo.land, this is the dotted expression, I get the individual fields from the object. And you can have you can access values within an array of objects by saying review has got reviews is an array of objects. You can say review of star.ratings will give you ratings for every value within the object stored in that array, right? We also have predicate support for objects. You can have an exact predicate here. You can also here it's an exact predicate. All of these are exact predicates. Let me go here. They're all exact. You can do not only once you get the actual value, you can also do the range predicates as well. Let me go within. Yeah. So once you have an object, you can have any number of nested levels. So you can use the within clause to search anywhere within the nested object. Yeah, we have object functions to manipulate the objects as well. So arrays, arrays is a big differentiator. We have talked enough about arrays, but basically it gives you true flexibility, right? You can have arrays of scalar values or arrays of objects within here, right? Arrays helps you represent one-to-n relationship and n-to-m relationship within JSON modeling, and we have large number of expressions, like we saw the any and every example, and within as another example. Along with that, we have a lot of functions which it's difficult to cover in our expressions to manipulate the arrays as well. Okay, let me skip over these things. Okay. Okay. In summary, okay. So in terms of moving from SQL to Couchbase and NIC, you are used to the concept of to think in terms of documents and buckets and so forth. Rows, think in JSON document. Your column is a key value attribute. Your index is index. You are used to dealing with JSON, SQL data types, JSON types. Here is where talked about schema and timestamps. So a join, inner join. Full set of joins in a future release. Primary key is a document key. Again, I won't go through statements, but we have and instruction. However, being the SQL guy I am, I mean, SQL has been enriched and evolved over last 30 plus years. Is to add more and more features. For example, right now we use rule-based optimizer, right? And nobody in NoSQL has a cost-based optimizer. We are thinking about it. We are doing research into how can you have a cost-based optimizer on a flexible schema, right? Those things are in our yeah. And how many of you have downloaded 5.0? Yeah, so that's one of the call to action. Download 5.0. One of the things I'm very happy about is, yes, explain will give you the whole query plan, but 5.0 will give you a visual query plan. Not only visual query plan with profiling, right? It'll tell you how much time it took in each of the stages of the plan, so that you can see where to optimize. And describing a table, describing a statement, schema is easy because schema is fixed. We have come up with an infer which can actually intelligently sample the data from your bucket and give you how many flavors of documents that are there. What type of field is this ID field? What type of field is this? What are the sample values in there? Infer will give you pretty sophisticated values. And in the web console, if you go to the bucket analysis, it also has tooltips to help you to do that, right? So this is kind of the summary of summaries in terms of the statements, query operations, schema, and our motivation is, if you can store it in JSON, you will be able to access it, manipulate it in NQL, right? Restriction, or just because you have structure. And the thing to remember is, in SQL, input is set of tuples, output is set of tuples or rows. In NQL, input is sets of JSON, output is set of JSON. Both are set processing languages. Like I said, we are inspired from SQL. We try not to deviate from SQL unless it is necessary to support JSON, distributed database systems, and so forth. And I think you can definitely, for the use cases that are suitable, you can migrate your applications or develop new applications using NQL. If you don't believe me, you can, yeah, Don Chamberlain has been advising us as well. So Gerald Sangudi was the original creator of NQL. So he, Don Chamberlain said, he not only invented SQL, he was part of the core committee that defined XQuery. And he said he argued against using SQL for XML for various reasons. But then he himself didn't think SQL could be extended to deal with JSON. So when he looked at NQL, he actually gave us assignments in terms of, can you do that? Can you do this? So he went through his own evaluation. Then he said, well, I think you are a worthy successor to SQL. So we are very pleased to have his blessing. And more than that, we are inspired by what you guys do in terms of developing applications and get it to production. We have a tutorial called query-tutorial.couchbase.com, and I'm telling everybody that if you know SQL, how many of you know SQL here? 98%. Austin. So everybody knows SQL here. I think using this interactive tutorial, you should be able to pick it up in 10 minutes. Right? It's not, even though I talked for long, when you actually try it out, it's actually quite quick. It does work in your mobile app as well, so please do that. And we have the Connect on 25th and 26th, and we have a very active forum. We love the questions from you all. We are very active. In the last 6 months, I don't remember a single day where there is an open question on NQL overnight. So please do that, and we'll share the presentation. We have a good number of resources. We even have a book. How many of you have this book? Okay, nobody. So if you need the book, just follow us on Twitter and send us a note. So we will ship you this book as well. This book is available as PDF, but some people like it as a book. Or you can talk to Bob and Mitch and tell them so they can also give you the book. Thank you, everyone. Thanks for staying next time.
Thank you, everyone, for coming. Thank you, Keshav, Murty. Keshav will be here for one-on-one questions. Come up right now and ask. Thank you all for coming.